Hi everyone, and welcome to the third of 4 videos where we're looking at some past exam questions on rate concentration graphs and also on the rate determining step. We've got some shorter questions in this video. This first one, we've got an equation here, and they've given us the rate equation. We know what's going on. So it's telling us that the I minus is second order, the IO3 minus is first order, and the H plus is second order. Okay. And then we've got some rate concentration graphs and they want us to draw them. Okay. So sketch lines to show the relationship between the initial rate and the concentration for the IO3 minus and the H plus. So IO3 minus we can see is first order because its concentration is to the power of 1. What does that actually mean if it's first order? Well, it means that the concentration is directly proportional to the rate. What does that look like on a graph? If it's directly proportional, it's a straight line, but it's a straight line through the origin. That does matter. Okay, I'm just going to get a ruler and do this, right? It does say sketch, but if it's a straight line, let's actually draw a straight line. And it does not matter, really, too much what gradient you put on this, but as long as it's a straight line that goes through 0, then you'll be fine. Okay. So there's our first order graph. The H plus is a second order reactant. So what that means is then whatever change you make to the concentration, you get that change squared with the rate. So the graph should look like a graph of y equals x squared, okay, which if you've seen that before is a nice curve kind of a shape. So it goes up slowly to start with and then curves and goes up more steeply towards the end. Okay. And that's all you need to do. Okay, it just, as long as it looks roughly the right kind of shape, we don't need to be too worried about getting a perfectly smooth curve or anything like that. As long as it's clear, that you can distinguish between this shape and that shape, then I think you'll be fine. Okay, the second bit of the question here, this is actually a totally different question. We've got another example here of a question about rate determining steps and suggesting a mechanism. Okay, and so again, this is a very similar question to the one from the previous video. So hopefully you can start to get comfortable with these kinds of questions, and again, you can kind of know what to expect if this type of question comes up. Again, they've given us an equation here and they've told us the rate equation. Okay, we can see that the H2 is first order and the NO is second order. This reaction takes place by a two-step mechanism. The first step is much slower than the second step. Okay, and then we've got to write this equation, this mechanism. Why have they told us this? Look, for one of the good clues in questions is, why have they given me information that seems like we don't need it? The first step is slower than the second step. Okay, if you say so, right. But that's actually there for a reason. That is telling us something useful. If the first step is much slower, then what that means is the first step must be the rate determining step. Okay, the rate determining step is always the slowest step in the mechanism. Okay, well, how is that useful then? Well, if you remember from the previous video, there is a link between the rate determining step and the rate equation. Okay? Whatever is in the rate equation is in the rate equation because it affects the rate, right? That's what it's telling us. And so if it affects the rate, it must be in the rate determining step. So the rate determining step must start with H2 and NO because that's what's in the rate determining step and that's what's in the rate equation. But because the NO is second order, it means there must be 2 molecules of NO in the rate determining step. Okay. H2 is first order, so there's only 1 molecule of H2. Okay. And again, we can see it's a 2-mark question. As we said in the previous video, you would get 1 mark for doing that part because that shows that you understand the link between the rate determining step and the rate equation. And then the second mark is for making everything else work. Okay. And by that I mean the 2 steps that we end up with must add up to give us this overall reaction. So if we then think about what the products of this first step are going to be, the products that we're trying to make are N2 and H2O. So let's try to make those products out of what we've got here. Can I make N2 out of this lot? Yes, I've got 2 nitrogens, so let's do that. Can I make H2O? Yes, I've got 2 hydrogens and an oxygen, so we can do that. And then what have I got left? I've still got 1 oxygen left over. Okay, so I could say then that I've got half a mole of O2. Then for the second step, we then compare what we've written here to what the equation is supposed to be. Okay? It's supposed to be 2H2 and 2NO in the reactants. Well, I've only got 1H2 and 2NO, so I need to have another molecule of H2 here. Okay. Then if we compare the products, I'm supposed to have N2 and 2H2O. I've got N2 and 1H2O, so I need to have the second molecule of H2O. And I've also got this problem where I've got this half a mole of O2 that is not supposed to be in the products. So I need to use that up. And you should see that that's going to work quite nicely then. That'll react with our H2 to make our H2O. Okay. Just to check then, we can see that the half a mole of O2 will cancel itself out from both sides. And then we're left with 2H2 and 2NO, as we're supposed to have, making N2 and 2H2O, as we're supposed to have. Okay, you should find that if you've done it right, whatever you've done here will fit nicely to work out in the second step. You wouldn't need to show this crossing out, for example, to get the marks. I'm just putting that in just so you can see how this adds up to give the overall reaction. That's not required as part of the answer.